And let's go ahead and get started. I'd like to welcome you to today's webinar on developing Azure Solutions. I'm going to now hand things over to our Microsoft Product Manager, David Mulkey.
Good morning. It's fantastic to be here with all of you today during our Microsoft Product Month. Thank you so much for attending today so we can have this in-depth discussion about developing Azure solutions. We're hosting several webinars over the month of March covering some of the most popular topics from Microsoft. So please check out our website to see our past webinars or to register for our future webinars. Developing Azure solutions is one of the keys to the digital transformation movement. Joining us today is Bob Thompson to walk us through some of the key things about developing Azure solutions. Bob holds his MCSD in App Builder and has over a decade in the IT industry, including some consulting work and project management work. So he brings a lot of real world experience to you today. And Bob is also one of our top tier instructors within the New Horizons Worldwide Network. So please join me in welcoming Bob Thompson. Bob, the floor is yours.
All right, David, thank you very much. Appreciate those words of wisdom, or whatever you like to call them, those introductory words. I hope I can live up to them. I do thank you for that. Thank you, everybody, for attending my little session on developing Azure solutions, and I really do appreciate you being here. One of the fun things about doing these webinars is you get a chance to learn a few other things that you don't normally get to see in your day-to-day work, right? And one of the things I came across when I was doing this one was the idea of using cloud services and considering them as a utility, and hadn't really thought of that before. I know that they try to make life pretty easy, but if you think of it like an electric utility, only it's a cloud provider that provides information technology. There's sort of a relationship or a way of thinking about that that's kind of may seem a little odd at first, but if you think about what electric utility does, provides electricity. We don't have a mini generating plant outside of each of our house to generate electricity, or outside of our business to keep it running. We're just used to going over to a light switch or whatever it is, turning it on, and boom, we got what we need. And we just then continue doing whatever it is we intended to do. You don't dream of having to buy, install, maintain all that electrical equipment that we need to power your home or whatever it is that you're trying to provide power to. What do we do instead? We just pay a fee or a local utility bill to the electric company in this case for any power that we do consume each month. We don't concern ourselves with thinking about the mechanics of generating electricity, or dealing with the capital expense of that, or maintaining the equipment, or repairing it after storms, and on and on and on. We don't worry about that. We just pay the bill and assume that's there. And when you think about cloud services, that's kind of what they tend to appear or want to appear as. You don't have to think about the infrastructure required for networking or hosting or building your physical hardware for a server that you might need. So it's really kind of cool when you think about it in those kind of terms. So we're not going to get into a lot about that, but that was one of the interesting things that I kind of came across when I was preparing for this. So my agenda today is not to convince you that cloud computing is what you should do. I'm going to presume that you are here because you are considering doing that. You can go out and find as many books, articles, and blog posts, and whatever you want that espouse why you should be using cloud computing and Azure in particular. There's just terabytes of information out there for that. What I hope to give you is just make sure you're aware of what Azure services are available, what you can have them for, and how you can approach using them. And then we'll talk about specifically some of these 6 items that I find most applications are using in one form or fashion, or at least commonly used. These are sort of the basic building blocks for many of the solutions that you would use Azure for. So we'll look at these and kind of give you a little bit of insight into what they are and how they work and how you might go about using them. So with that in mind, let's talk a little bit about the Azure services. Again, going back to that utility analogy, you don't really need to know how the computing power or services in Azure are going to be provided for you in the cloud. All you need to know is they're there and you can use them. Someone else takes care of all of the underlying physical aspects of that in that kind of sense of the service you're wanting to use. So moving your compute, storage, and network to Azure is really just like turning on a lamp in some respects. I realize that it's not that easy as plugging in a lamp and working. There's a little bit of work you have to do, but it should be almost that easy. And you also pay for what you use in most of these services, so it's kind of like the same analogy of that you turn on the light, you pay for it when it's on, when it's off, you're not going to get charged for that. So we're going to look at a couple of these services that you'll see here, and just a general description. If you haven't ever worked with Azure, it's a cloud computing service that Microsoft offers. It's a collection of many different services that you can use to host existing workloads or existing servers. You can use it, the managed services that they provide, instead of having the workload on your own environment. And you just use their service, and you can also create new workloads that can be deployed to your customers or use them for yourself. It is a global network of data centers all across the globe. They're continually upgrading and adding new data centers as time goes forward. And it does support many programming languages, tools, frameworks. One of the earlier, when they first came out with Azure, it was called Windows Azure, and I think that a lot of folks thought it was just limited to simply Windows environment. But they have since kind of renamed that in the past few years. It's really Microsoft Azure. It does support Windows, but it also supports other things that may run on like a Linux environment. So it's much more widespread than just a very focused type of item. And you use these different services that are out there. You combine them to provide systems or services that are robust, resilient, and they can stretch and grow. They're somewhat elastic depending on how you set them up. And they can be global very easily. So there's a lot of interesting things that you can work with on these services. As far as services go, you may have seen this slide before, and I have another one after this, but it's important to kind of understand where these services lie. You'll have what I call SaaS, or software as a service. Really, it's a complete solution for your software. You basically are signing up to use an application in the cloud, like Microsoft 365 or Skype or Microsoft Dynamics customer relation management system online. So the advantage of using these type of services is that the user doesn't have to have any kind of installation as far as getting access to these apps. They're out there, you use them, they set up, and you work with it. And users don't have to worry about updating the apps or maintaining compliance, because Azure takes care of that. That's a service provider, and they deal with those things. Product as a service is, or PaaS, is kind of where you have services and you use them to, these resources to build your own solutions. Like if you want to have a database in the cloud, but you don't have the resources or a database server, they offer that service, and we'll talk about that in a moment. Normally, these type of offerings will have a programming API that you can work with. There's also configuration and management interfaces that you can use either through a portal or through some PowerShell or some other ways to get to it. With these types, developers and your organization can create custom applications that can be scaled up or down as the need needs to be, without having to provision and go out and get the hardware and support it and handle all the operating requirements. You're just focusing on what you need with that. That would be like the Azure Web Apps, which we will talk about, and inside of Azure App Services, where we can just create a web app, deploy it to a app service within Azure, and it's available. We don't have to worry about getting the server and making all the connections for it. IaaS, which you get into infrastructure as a service, is a way to let you have more control over the environment. It's really the infrastructure is the networking, the servers. You can provide a virtual server and you have total control over it. It would just be like you take your physical server that you can touch or kick, as the case may be, and you move it to the cloud, and you no longer see it, but you are interacting with it. So that's a common way that a lot of companies do start off working with these, is to take the physical aspects of it and work in an infrastructure. There are other service offerings. As time goes on and cloud becomes a little more mature, and you find different services being brought up and evolving, you're going to run across some other ones like identity as a service, where now you have the need to handle user authentication or providing information about a particular user before you give them access, or maybe a business client that you want to work with. Azure has that in their Active Directory, Azure Active Directory. We'll talk a little bit about that. Or maybe a disaster recovery as a service, where you have cloud-based backup recovery services. You can make those consumable on a pay-per-use model, make them highly available and scalable to meet the demand that you have. In which disaster recovery, I had a little bit of an auditing background. I remember working with companies, and they would always have on paper a disaster recovery plan and it looked good, but they never really tested the darn thing to see if it would work. Well, using that type of a service is a great way to actually put a plan into place and test it out without really impacting any of your ongoing production. I won't say it's an easy way to test it, but it is a very good way to make sure that you have everything in place so that you can resume your business very quickly. This is kind of the same thing, but it's kind of working toward getting into some of these things that are within the infrastructure, platform, and software as a service. This is where some of you may be today, and I won't say that that will totally go away. You usually want to retain some type of information, whether that's confidential or you just need to have it local. But this is where you're managing everything you see here, your applications, your data, all of the software that's needed to support it, and the physical servers and storage and all of the networking. You're responsible for all that. When you talk about IaaS, you're basically taking away the virtualization, the servers, the networking support. That's going to be handled by Microsoft. You still use it, and you're going to be required to deal with the software and the applications and data with that. You go to platform as a service, then you're picking up a little bit more. Now you no longer have to worry about the infrastructure part, or now you don't have to worry about the software either. You can put your applications out there like a web app. You can put your data into a database or a storage queue or storage table, as the case may be. So that's a little bit more. And then you go to software as a service, where everything's out there. You're just using the darn thing, as I say. The analogy I use in class when I talk about this is infrastructure is kind of like using a cabin. You know, you got the four walls, you got a roof over your head, and that's about it. You don't have any plumbing, don't have any water, don't necessarily have any electricity. You have to cut the firewood if you want heat, or cut a hole in the wall if you want some fresh air. So you have that. Platform as a service is kind of like where you go into a house. It's an upgrade. You still have the four walls and roof, but now you got plumbing, heating, air conditioning, electricity, and all that good stuff. Software as a service is more like a hotel or even a motel to some degree, but here you have the four walls, roof, you have electricity and the running water, but you also have someone who's taking care of the room, keeping it clean, making the bed or turning it down. All you really need to do is exist in that room and use it. Watch TV, you know, take a shower, whatever. You don't have to worry about taking care of it. That's somebody who manages that. So that's sort of the analogy I put in mind. There's other ones out there that do the same type of thing, and the other common one is a pizza place. But we're not going to go with pizza because it is close to lunchtime, and I don't want to get too hungry while I'm doing this. Okay. So these are some of the services that Azure has. There's, I think there's 10 groups shown on this slide with 68 different services shown in those. There's probably some things, well, I'm sure there's quite a few things here that I missed. And if you really want to see all the services, you'd have to go look at the website for Azure and you can find them. But this is it's a good overview of the different categories they have. They have like the compute, which is where you're going to have some virtual machines or functions that you can have. These things in cloud services where you're creating compute instances and actually working with servers in PCs, if you will. Web and mobile, you've got Internet of Things and enterprise integration, security, identity, and all of the other ones. I don't think I need to read those to you. So it's a matter of picking these up and deciding which one of these you really need to use. And we're going to talk about these, but thankfully we're not going to talk about all of them because we really don't have that much time to work on that. So we'll just pick a few of these to work with. So whenever you're thinking about your solution, you really need to think about, well, which piece of these do I need? You know, I mean, you could start off by identifying it and not even consider a cloud platform. You can think of it all in-house, but with all of these different choices, it can be a little intimidating or a little confusing as to which one might be best. Which one should you pick as a developer? Which is why I picked these, because they're a little more understandable, a little more commonly used. Not necessarily the ones that would fit to every project, but one that you would pick and choose for those. So in the majority of the projects or workloads, you're going to just use probably a handful of all of the services that are available. When you build and test and deploy these, you can choose to use as few or as many of them as you need to make things happen the way that you want. For instance, if you want to have a database that exists and you want to move it out to the cloud, a virtual machine would be a good way to go, or you could actually port it over to an SQL database, and we'll talk about some ramifications of doing that, things that you should consider. And that may be your starting point. Then maybe later on you'll want to use some storage out there, so you can kind of have it evolve as well. So thankfully, we're not going to go into detail on all of these items. I picked a few that I think you might find interesting to help develop and support distributed applications. Oh yeah, there we go. So virtual machines is the first one I want to talk about. Virtual machines are going to be a way of hosting your application. There are several options for hosting, virtual machine just being one. There's also containers, there's Azure Functions, there's logic apps in Azure that you can have. There's cloud services and Azure App Services. We'll talk about virtual machines as well as Azure App Services in this particular session, just to kind of give you an idea of what these are. You'll find that, you know, when you work with this cloud provider, or any cloud provider, but Azure is the one we're talking about, it's not like magic. There is something physical that has to be running this. So those are just probably commodity type servers, and they got thousands and thousands upon them in the various data centers that's actually doing this work. They're kind of put together in a way that provides the services you want. So when you think of virtual machines, there's really the type of virtual machine that you can create to do exactly what you want to do, which is the one we're going to talk about. But realize that almost everything that runs in Azure will have some type of underlying virtual machine supporting that. It may be a shared machine supporting many different tenants, clients, but there has to be something, a CPU, that's actually processing the statements that you need. So those are like with a cloud service. When you deploy it, you don't actually provision the server that runs your service. It's provided for you through a virtual machine that Azure provisions and takes care of. Okay, so let's talk for a moment about just what I mean by virtual machines. It's a compute on demand, and again, it gives you total control, or I shouldn't say total, it gives you lots of control over how you host the application. But when you create your own virtual machine, you're going to be responsible for maintaining that environment, such as patching the operating system, keeping the antivirus programs up to date, and so forth. You can use, for instance, create a machine as kind of a throwaway machine. If you have a new version of some software, let's say it's Visual Studio, and you want to see how well it's going to work, you can create a machine, install it, test it out, and see if you like it. You're not going to get any of your existing machines dirty. When you satisfy yourself that it's okay, you can release the machine and you're done with it. So you can use it for just that time period. It's compute on demand is really what it is, and you only pay for the time that you're using it. These are all based upon Hyper-V virtualization. You work with the Fabric to actually you make your request of what you want. The Fabric will then have a controller that will deal with the creation of that through your Hyper-V. You can also create hard disk on your own on-premise environment, create that machine image and upload it, and then create in the cloud a virtual machine based upon that image. So it's basically clones it in that environment. So it's kind of easy to work with those. There are a lot of existing images. You can go to some sites, some open source ones that have images that you can use, but there are several of them already provided Microsoft, so you can quickly create a SQL server or SharePoint or a BizTalk server if you want to. So those are what I do in one class is we create a virtual machine that we use for all of the testing and all of the labs activities we do. It already has Visual Studio installed and works very nice in that sense. So you can get all these in the management portal, a lot of third-party images, source and open source ones as well. Often you'll see these workloads mimic what you're trying to do on premise. So they can be basically exactly the same, except they're going to be in the cloud, obviously, and you have to perhaps connect with them through your network slightly different, but they're not going to operate any differently in that sense. Like web applications, you'll see web servers is a common one that we have, particularly for like web APIs where we need to deploy those, make them available. SQL servers, state servers. SharePoint is another one that is commonly used. You have web front ends or a need to have web apps up front working with SharePoint. This is a nice way to deploy them. Kind of separate them out from the SharePoint environment on premise. SQL servers, app services, and you also have other types of not necessarily support of applications, but support of the environment that the application runs, like backup or recovery. Backup is a very simple backup solution. It's automated and it uses some of the other services that are available in Azure as well as Windows Server to attempt to minimize the effort that you have to put in when you're trying to back up your data. It's encrypted in transmission, so it does move it around, backing it up in different locations. It won't be available if it is intercepted, and it does integrate with your system center as well as the 30. And once you have a backup, it only changes incremental changes. It's not going to pick up the entire file unless you state that you want that. We also have site recovery. It replicates to private clouds to a secondary location. So it gives deep orchestration and monitoring functionality, so you can make sure things are going to be in place if you should need them. You can quickly recreate the virtual machines, and it also is integrated with some of the Windows Server functionality that you may use already. And again, it connects to System Center, so you can watch the health of it, make sure that it's always running, available if you should need it. So virtual machines, again, are going to be two flavors of them. There's ones that you create and manage. Those are the typical ones where I think of taking a server and punting it to the cloud, and you still use it as you would, as if it was on premise. And then there's virtual machines that are underlying just about everything that you do without you having to create it. Azure is going to provide, provision those, and then you will use that service that's deployed on that, but you don't have to worry about the virtual machine software and starting it, stopping it, and all those types of things. Besides hosting your app in a virtual machine, you can also host these in one of the core service offerings in Azure. It's called Azure App Service. Azure App Service has several different types of ways to host and orchestrate these services. Like web apps is one we're going to talk about, but there's also web app containers, mobile app. Then there's some other things that we can also use. Those are the main ones, but they do share features and capabilities, but each one of them will have their own unique characteristics that they bring to make available to you. So some of the common features include scaling, deployment slots, continuous delivery. They can connect to on-premise resources if you need to have kind of a hybrid type of application. You need custom domains as well as certificates. Those are all types of capabilities that you have through web apps. You can also secure them using Azure Active Directory if you want to. So web apps, it's amazing how quickly you can deploy a web app using the service in Azure. So this is where an example of where there is a virtual machine that is supporting your web app, but you're not necessarily responsible for that machine at all. You're responsible for the application and deploying it, but the machine that is actually you're hosting it and running it is going to be provided through Azure. It's very simple. It is scalable, so if you start off that you find that I have sufficient traffic to keep it at a certain level, if that should jump up very fast, you can add additional instances of that so that it will handle the traffic. There's a load balancer in front of that will automatically direct the traffic to all of them that you have. That can be auto-scaled as well based upon different metrics. Like if the CPU achieves or raises above a certain threshold, like 70 or 80%, you can have it automatically add in 1 or 2 or 3 instances, whatever you need, to bring that volume down or that effort down of that CPU to a manageable scale. And if it goes below a threshold, you can also have it remove those. So it handles the traffic surges and unuse automatically. You said it kind of help you control your cost a lot better. You do have integration with Git, Team Foundation Services, GitHub. So you do have some continuous deployment with these if you want to use that. And it has support for those different types of commonly used applications like WordPress, Drupal, Joomla, those types. And you can also use just about any kind of technology when you're writing these apps, like .NET is a common one, or ASP.NET or MVC, Java, Node.js, PHP, and the other ones that you see on here. They can work quite fine with web apps. There are different tiers for these depending on what you need your web app to run and what kind of support you think you might need. Like there's a free tier. Free is kind of a good way to at least test out some things, and since it's free, you might as well use it for some very simple things. It is a shared resource, meaning you're running on a compute resource that other clients are also going to be using. So you have a little competition for resources in that, but you're limited in what you can do in bandwidth and CPU time anyway, and you have very few customization options you can do. But as I say, what do you expect for free, right? You're going to get something out of there, and you can kind of start off with that. When you get into the shared, it's a pay. It's where the payment starts. It's a lower cost because it is a shared compute resource, so there isn't really a bandwidth or CPU limit on that, and it does give you some customization options on that. And you can see as you move from shared to basic to standard and premium, you're getting more functionality. So if you need to have websites that are going to be pooled under the same instance so they can work together better, then you're going to have basic. When you get to the basic, standard, and premium, you have a reserved compute instance. You're no longer sharing that resource with anybody else. And so you'd expect to pay a little bit more for that. Standard, you get same thing, but standard is the level at where auto scaling comes about. Now you can create other instances of these, but auto scale is something that a lot of customers that use Azure want because it helps them control the cost dependent upon the load that they may have. They may not have much of a load on weekends, and they may not have much of a load in the evening. So during the weekday, in the morning, and through the early afternoon, they may have multiple instances, and they want it to automatically scale back down so they don't have to pay for all of the different instances. And all of the tiers, when you start talking about premium, you're usually talking about very high volume, very quick response type of applications that need high security, and you want them to be isolated from anything else, so have that capability. There are images that you can start off with. I think I mentioned this already. Similar to virtual machines, you can create a web app using one of these templates. Like if you're trying to create a WordPress, then you have an image out there that you can select, and it will create that for you. Go ahead and install it and move it on. Or Better CMS or Umbraco or whatever one of these images you want to use. These are a few that are in the marketplace in Azure, and there are several others, of course, not shown on this, so those templates make it much quicker for you to create one of those. If you're doing a custom application, you're not likely to use one of those, but there are some pre-built ones that you can work with. Okay, now when you get into the hosting, okay, usually you're going to have data that's going to need to be accessed or stored for your application, regardless if it's a virtual machine or one that you're creating or you're using some service like a web service. And so data, of course, is going to be a key part of any modern application. I shouldn't even use the word modern. It's probably key to any application, and it can come in many different forms and fashions and shapes. Azure does provide several different types of data store. We'll talk about a couple of them. SQL Databases is one, and we'll talk about the things that are available for storing into storage accounts. But you can choose from an SQL database, a MySQL database. I saw where, I don't know if it's this Thursday or next week, but they do now have a service that's equivalent for using Microsoft SQL database. They will now support as a service MySQL, which makes it very easy to work with Linux deployments if you're using that type of database. You also have Cosmos database, and you have blobs, tables, queues, and others that belong to storage, and we'll talk about those in a bit. So when you use these services like a Azure SQL database, you're not maintaining the virtual machine that's hosting the database server. You need to define the database with an administration ID and a password and those types of things. And you specify how much computing power you want that server to have so you can support some number of transactions that are going through it. You just simply specify that it provides the server that will interact with this SQL database that you're going to define. So you create the database, set up the server, and then you just use it. Since it runs in the cloud, it's going to be fully managed by Azure. It's going to be scalable, automatically backed up, and some other interesting things as well. So this is talking about Azure databases, and we're talking about this as a service. So you have limits on each of these. So you have basic, standard, premium. So there are size limits for each of these different tiers that you can use. Basic is, the lower end of it. I think have up to 2 gig, if I'm not mistaken. And then premium, of course, you can have very, very large databases, but you do pay a little bit more for that. Each of those basic, standard, premium also have different throughput units. A throughput unit, or a DTU as they call it, is a measure that is a blended number from CPU usage of memory and some other factors, so that you can compare basic, standard, premium to make sure you pick the right level of support that you want in that. This is perfect for new cloud-based applications, because if you're going to deploy it in the cloud, you might as well have a cloud database, because it's very easy to work with, and it don't have a pre-existing database. And you can also restrict these. When you create these databases, they're shut off. There is no firewall access. You have to open up a port actually to get to that, or an IP address to allow it to get access to it. If you have an existing database, they can be moved into this. You have to migrate it. And if you don't rely on any special customizations in your SQL, it might be a straight migration into that. But if you use some different things that may not be available in the Azure SQL database, you might have to do a little bit of tweaking in your application. Re-architecture is the term that's used on the slide for your application to make use of that. This is a picture I put in here just to kind of give you an idea of how many of these services operate. This is your database instance right here. So you're creating a database that it lives inside of a server that you define. You do not create the server. You create the database through the server, through your management suite or through your application code, but you don't provision any of this. You interact with the server and your database through the service provider, the Azure components that you work with. And it manages that for you. So you're creating this inner stuff, but you're not having to worry about the hardware for the server, making sure it's up to date, running. You don't have to worry about any kind of database software either. You just need to create it, make sure that's available, get the connection string, and then begin working with it. As far as the transactions go, they are not considered committed until you have 3 copies made of that. Okay, so when you make an update to a database, it's going to be written to the target database. That's your main database. There will be a primary replica and 2 secondary replicas. So essentially, you've got 3 backup copies at a data center level that you can use. So that makes sure that if at least where the database is housed, if something goes wrong with that, heaven forbid somebody pull the plug on it or spill Coke on where your target database is, you do have replicas that are current, up to date, that can immediately be switched over and used until the other ones gets repaired. You can use them for backup and restoration of those as well. So if you do have some transactions that are corrupt or got messed up in there, you can back it up to a certain level. The database is backed up as a whole and can be recovered through a portal if you want to do that. And you have a retention period that allows you to go back depending on the tier of service. So basic gives you 7 days of recovery, standard is 14, and premium is 35. Then you have different types of parameters as far as restoring the database if something goes out, again, depending on the tier that you're at. So you got high compatibility with SQL on premise, so you can work with that. Now this one is slightly different. If you don't want to use a service, or you can't use it because the database you have on premise you're trying to migrate is so unique, then you might need to create a virtual machine that's running as an SQL server and house your database there. So that would be almost like a straight clone, but you can run an SQL database and work with that. That just means you don't have to do the customization that you might otherwise have to do if you're using a service database, as using Azure Database Service. This is just a virtual machine where you have the SQL installed and you're running it. So that would be just like any other connection, but you're back in the business of maintaining and customizing the software or if you need to have some kind of scalability, maintain it. Storage blobs. This is another way for you to store data. You got blobs, tables, queues, files, disks. We're going to spend a little bit of time on those. I kind of wanted to talk a little bit about these. All of these have some different characteristics to them, obviously, or you wouldn't have them, but they do have some shared benefits like geo-redundancy. So you can replicate these to different data centers so that you can quickly recover it in the event of an individual data center because it fails, which is unlikely, but it's possible. You have encryption of data at runtime if you need it, and they also give you custom domains that you can use for referencing. So storage is a key part of Azure. Anything that you really do, you have to have some place to store the information. Like when you create a virtual machine, or let's say you're running a cloud service, that cloud service is going to exist not on a machine that you create, it's going to be on some compute instance, okay? And you can have as many of these as you want, but you're going to have something that explains what the service is running on this so it can recreate it if this machine goes down. Now, you may have multiple instances running your application, so that's good if you have that, but you have, if one of these should go down, you're going to have it restored, and that's where storage comes in. There's an image of this data. If it's a virtual machine, there'll be an image that says you can have uploaded and recreate it, or if it has a configuration for your service. So you'll find that storage is used almost throughout the Azure, but if you're using just like an SQL database, you really don't have any storage. But if you create a web app, you do have storage because you got to have a place that describes the web app and store it so it can work with those. It is scalable. It's for massive amounts of data. I can't say if it's low cost, but I would say it's probably lower cost than you trying to do it in-house. And you're only paying for what you need, so you don't have to worry about overbuying or underbuying. You're going to pay for just what you need. These are three types of files access, and that use that term file loosely. There is a file that lets you create like shared service, shared files that you may need to have available. So that's one where it uses server messaging block so that you can use it with Windows and Linux as well. It's also scalable. Disk is essentially the same as file, but it's more for a premium area for high I/O and high performance devices. And blob is a way of storing binary large objects, just a bunch of bytes, which may be a video, maybe an image, maybe a text file, could be really anything. It could also be an image of your hard drive that you created through Hyper-V that you're storing. There's two types of these. There's what's called a page blob, which is used for random access, like virtual hard drives or a drive that's associated with the virtual machine. And there's block blobs that are organized for uploading, downloading blocks so that you can have them done do very fast. So they're different, very efficient uploading and downloading of data. Queues are a way of using storage. These will hold large volume type of messages. It's very low cost, simple, and it's resilient, and it holds massive amounts of data. But this allows you to create disconnected applications. So you can have your web front ends working, sending information, and you don't want to be waiting for the back end. You put messages in there, and another process in the back end, when it needs to run, will pick it up and run. So you have a good way of decoupling it. We'll see this also again when we get into service message bus. Table is a way of also having a NoSQL database. We're talking simply types of data that have no particular schema associated with it. It could be structured, but it could also be unstructured, unlike an SQL database that will have a very fixed layout. This doesn't have to have that. And the data can be partitioned based upon the key and the value so that you can quickly find the data. So it's made for large amounts of data. And then archive is exactly what it sounds like. You archive your data. Service bus is another type of messaging, and it falls into this area of Internet of Things and enterprise integration because it's made for messaging and getting the message from point A to point B and have your application work in a decoupled manner with scaling in mind. So there's several services that are provided through the service bus to help you with event ingestion and processing those, as well as doing analysis of that. A service bus, if you haven't worked with that, does require some type of namespace in which you can create different types of services that you may want to have available within. So again, it's kind of a broker type of messaging. It's massive in scale, completely managed. You can scale these out or as need to be, but it really gives you the ability to have decoupled components, and you can do this async or synchronously. But it makes sure that it's a very managed type environment as opposed to storage queues, which is also managed, but it's not going to be the same type of processing that you would find in like a service bus queue. You can have service bus, and you can have topics and relays, publish descriptions. This is an example of a service bus queue where you have message senders over here, web app, mobile app service, where it's putting messages into a queue, and you have a message receiver. The idea here is, let's say that you have an application that users are placing orders. Okay, so the orders are being placed. If you don't have a queue, let's say that this order is going to go over here to this and be processed. It may take several minutes for this order to be processed, picked, billed, and all that. If that's the case, then you're probably you don't really want the user to be waiting 5 minutes or a couple minutes for that. That's too long. So what you can do is have them put this in the queue and tell the user that your order is being processed, and then you can have this back-end service process the queue and do what it needs to do, and then send an email back to the user, say your order's been processed. So you decouple these through the use of the service bus queue, and this allows you to scale this completely different from this. So if you have lots of these messages or web apps need to be scaled up, then great, you can add more or scale it down. If you have too many messages in the queues, you can always increase the receivers that are processing those, so you can process more messages without impacting one type of structure or hosting environment. Relays give you the ability to connect applications to or cloud services to on-premises endpoint or within the cloud if you want, but it's really ideal when you have something on-premise, but you don't want to allow public access to that. So we want you to be able to get to it, but we don't want you to know where it's at. And the relay handles that. You have your service register with that, so it knows where it's at, and the relay will then be able to receive these messages, pass it on to the service, and then the service can give the requested information back, and the relay will pass it to who needs it. Those can be one way, or they can be bi-directional, as the case may be. Azure Active Directory, when you start getting into security, you get, got to make sure you do it right, because it's not simple to do it. We've seen news reports of companies who don't do it quite right. You would think everybody would encrypt their information, so in case it does get away, at least they would have it, but that's not always the case. Fortunately, Azure does have several services that we can use to make it simple for our application. And you can have it not only be just for cloud applications, it can be used with your software as a service, used with any other type of application hosted in the cloud. It can also be worked with your on-premise, and you can keep your on-premise Active Directory, because this is not a replacement for that, as you'll see. So when we talk about application security, authenticating users, we want to make sure that the right people get to the right information, and only the right people see the information they need. So you can focus more on your domain, the application, the users, without having to worry about this underlying work that goes on to handle the authentication. Supports single sign-on, so it makes it a little bit easier for your different users to get access to the same applications that they may use without having to sign in on every one of them. It does support standard protocols you see there, and it does extend your existing directory to the cloud. There is a syncing mechanism that you can use depending on which tier you use that will keep things in sync, so you can have it kind of right back changes that have been made from one place to the other. Also handles memory or password reset as well, so you don't have to have an administrator for that. This is just a slide to kind of show that it isn't a replacement for Active Directory that you have on premise. This is your on-premise over here. You still have Active Directory, but the Azure Active Directory is going to be working with your app in the cloud, okay, or it could be with on-premise. But this slide kind of shows all of the different connections or different communications of messages that are going to be using either the Active Directory or your Azure Active Directory in order to handle the information. So if you have cloud apps, they can use this. You can also have it support your on-premise application. So you have the directory services where you can create, modify, handle user accounts. That's your typical thing you think of, managing passwords. There is syncing between the two if you need to have that. There's also extra layer of authentication that you can use with multi-factor authentication. Multi-factor authentication adds on usually the idea of what you have. So when you typically log in, it's something you know, right? Your ID, your password, supposedly only you know that. If somebody else has that, they could log in as you. So multi-factor authentication is usually something that you have, like your phone, you get a text or some other kind of ID that you can use for that. So you can use multi-factor authentication for both on-premise as well as cloud applications. So that works as well. All right, that brings me up to my end. And so I know that was sort of a brief review of those 6 areas. Didn't really get a chance to dive down into some of those, but hopefully you can get an idea of how you can use Azure to approach these distributed applications using the Azure services. So remember, if you think of it as a utility, you should be able to just rely on it always being there. And in essence, it is. You still can interact with it. You need to do a little bit more. It's not as simple as flipping a light switch, I'll admit that, but you can kind of conceptually view it as a utility in that sense, where you can host your existing workloads, move them straight out there. You can create services that you may want to share with others as a brand new packaging of the Azure services that you can market and sell, or you can take what you currently use in-house and use one of the services to ease the administration that you might have. One thing that really isn't part of this, but there is an Azure trial account that you should check into. There are services that you can actually go in, allocate, and use and play around with and see what you have. For 30 days, you get a $200 credit, so you kind of get a sense of the cost for the various things that you use. You do get 12 months of free services with the trial of certain things, not everything, and you'll have 25 plus always free services like the free websites and things like that. So it's a good thing for you to check out. If you haven't checked it out before, look at the Azure trial and explore it and see what you think. I think you'll find it kind of fun, if nothing else, to see what's available, kind of have a better idea of how you might interact with it. That is all I've got right now, so I thank you for your time. I don't know if anybody had any questions or not, Kelly, but I'll try to answer them if I can. If I can't, I'll have to look it up and give you an answer later. But I do thank you for being here.
Thank you so much, Bob, for taking the time to present on behalf of New Horizons. We really appreciate it. And thank you again, everyone, for joining us. If you guys have any questions at this time, we'll save some time and we can answer those over audio. In the meantime, while you're thinking of those questions, wanted to direct you guys to our website at newhorizons.com. If you are not familiar with your local New Horizons, you can do a zip code search to find the center nearest you. There you can also see a full schedule of upcoming classes, on all of the various topics that we offer. So please visit newhorizons.com. If you click on the webinars link, you'll see an updated schedule of all of our webinars coming up through July, and these are free for you to attend. So please take advantage of that. There is also a webinar archive library on our website where you can access over 50 of our past webinar recordings. So those are just some great tools for you guys to have. Also, a reminder that this session is being recorded, and you will all receive a link later today to review the session or pass on to any colleagues who were unable to attend. Okay, Bob, it looks like we've got a question on what are the reasons for people to choose Windows platform instead of Linux and vice versa?
Well, that's a good question. It's not really anything related necessarily to Azure or any other cloud service. In my mind, if you're more of a Windows shop, you're going to have resources who are used to developing in that framework, and you're probably going to work with those. If you're concerned about cost, there's going to be a cost with most of the Microsoft products like SQL Server and things like that. So if cost is an issue, besides just the resource experience, then you may want to go to one of the more open source or like a Linux platform. Linux is not going to run certain types of applications, like you can't run an MVC or an ASP.NET. It's got to be an IIS type of environment to support those. So to some degree, it depends on the nature of your applications. If you're going to be running PHP as a backend, I'd probably go with the Linux because it's going to be more of a lower cost type of operation. But I don't know that it's actually a distinction between Windows or Linux. It's kind of to me, it's more of well, what am I comfortable developing in? What resource do I have to create these things? Are they more of a JavaScript node type of environment? Then that will kind of direct you one way or the other, in my opinion. So I don't know if that's a good answer for you, but there's, it's not just a toss-up of a coin to say one or the other. It kind of comes down to cost, because there is some fees associated with using Microsoft stuff. Even if you use a Linux type of platform for a web app, you're still going to have a cost, but it's going to be probably a lower fee if you're using Linux versus Windows. So that's kind of how I would answer it. If there's some follow-up on that, Kelly, I'd be glad to try to address it.
Okay, thanks, Bob. Yeah, it looks like that was it for that question. I don't see any other follow-up on that, but thank you. And it looks like that actually is it, all of the questions that we've had. So thank you again so much, Bob. I really appreciate it.
All right, thank you.
And thanks again, everyone. I will be sending you the recording link later today to review the session. Thanks again for joining us today. You may now log off. Have a great day.